So good afternoon from a beautifully warm Cambridge. My name is Liz Woodham and I'm a member of the NRICH team, and I'm joined this afternoon by Ems Lord, who's the director of NRICH, and Charlie Gilderdale. And what we're going to aim to do this afternoon is work on some mathematics together from the latest primary feature. We'll be asking you to contribute your thoughts via the chat facility. So do post, and don't worry if what you're posting doesn't feel like it's fully formed. Please post anyway. We'd much prefer you to offer something, even if it's not polished. Before we start the mathematics, I'd like to thank Trinity College here in Cambridge, who fund these webinars, and which means that they're free to you as participants. So I'm going to share my web browser now, and we can get going. So here is the NRICH homepage. Those of you who've joined us for webinars in the past will be familiar, and many others of you as well. Before we go on to our current feature for primary teachers, I'm going to show you a few other parts of the site which are key. We're going to start by going to the primary teacher homepage. The best way to do that is up here in this top menu bar, this light green button. And if you were not already aware, one of the main places that my sort of go-to place on NRICH is this purple box here, which is all our curriculum support. So if I click on this link here, the curriculum support, you're going to get a page up which is your portal for all things curriculum related on NRICH. In particular, you may be interested in our curriculum mapping documents, where we take objectives from the curriculum, we link them to NRICH tasks. So one way to get to those is via that link there. Alternatively, you can get there, I'm just going back to the primary teacher homepage, you can get there via this link, and that will take you to a Google Sheet, which is direct links to the tasks, as I say, that link to curriculum objectives. Do look at those if you're not familiar with them already. They're a great way into the site. Today, what we're going to be looking at is over on this blue box on the right-hand side is our current feature, and I'll explain a little bit more about that in a moment. As well as our current feature, so our newest resources, you can see that there's a link at the bottom of the blue box to all our previous features, so everything that's come in the past. So do investigate those as well. Right, let's go to the current feature, which you'll see is focused on pattern and structure. Now, rather than me talk a lot about what we mean by pattern and structure, I think we'll just get going, have a go to task, and then we can reflect afterwards. Throughout the session, Charlie and I will do a little bit of a double act. We'll work on tasks together. Charlie doesn't know the primary tasks quite as well as I do, because Charlie is our secondary coordinator. So I'm going to be challenging Charlie to solve a few of the tasks, tell us about his thinking, and of course we'll be inviting you as participants to join us as well. Are you ready, Charlie?
Okay, I've unmuted myself, so yes.
Great, good. So I'm just going to scroll down the feature. Each of these links is either a problem or an article, and we're going to go, the task we're going to look at first is called domino sequences. However, I'm not going to show it you on the NRICH site yet. Instead, I'm going to stop sharing my browser window, and I'm going to share via the visualizer instead, where I've got some dominoes lined up. Charlie, can you nod at me if you can see these dominoes?
I can see them.
Wonderful. So here, Charlie, I've set out, we've got 4 dominoes in a sequence here. And your challenge, please, is to think about what those 2 dominoes could be. Okay. So for those of you at home, have a little think yourselves. Well, I say home, you may not be at home, I'm assuming you're at home. Those of you out there, have a little think as well. Charlie.
Okay, I'm glad you've started with something relatively easy. So this is reassuring. Okay, so the top half of your dominoes all seem to have 1s. So I'm assuming that the next 2 will also have 1s at the top. And the bottom, I think of the blank as being 0. So the bottom seem to go 0, 1, 2, 3. So I'm assuming 4 and 5. So 1 and 4 and 1 and 5 for the two dominoes.
So let's have a little look. 1 and 4 and 1 and 5. And did you notice how beautifully Charlie explained his thinking? So one of the key parts of this task is not only to encourage children to identify the patterns and to tell you what they think the two dominoes might be, but explaining why they have reached that conclusion is really key here. Thank you, Charlie. Ready for another one?
I'm ready.
Okie dokie. I'm going to shift this up a little bit. Okay. So just make sure you can see these, and they're relatively straight. I find it so difficult to orient these things into the visualizer. Right. So here we go. Sequence number 2. You're
just giving me 3 this time, are you?
I'm just giving you 3.
Okay.
But again, I'd like you to think about what are the next 2 dominoes in the sequence. Those of you watching, have a little think yourselves and think about how you might explain your conclusions.
Okay, so one of the things I notice is that the difference between the top and the bottom is always 2.
Nice.
But that doesn't really tell me what comes next. So to work out what comes next, I'm going to look at the top half separately from the bottom half.
Okay.
So the top half, starting on the left, goes 6, 5, 4. So I'm assuming 3 and 2 for the 2 that I can't see yet. Whereas the bottom half has started with 4, 3, 2. And so both are going down by 1 each time. So the bottoms are going to be 1 and 0. So I'm assuming the first domino is going to have a 3 at the top and a 1 at the bottom. And the final one's going to have a 2 at the top and a blank at the bottom. So the difference of 2 is maintained.
Great. Thank you, Charlie. Brilliant. So, I mean, as Charlie said at the beginning, the mathematics here is not difficult, but it's about challenging children to do the explanation. And I think the difference between this second sequence and our first one is Charlie was very explicit about the fact for the first sequence, we had the ones, the top numbers, stayed constant. So we could sort of admit and forget about that temporarily. That was sort of out of the equation. We could focus on the bottom. And so here in this second sequence, we've got the 2 patterns going on at the same time. Now, actually, in this case, as Charlie has very eloquently described, the pattern is the same, but they're at a different starting point. Fantastic, thank you. Now, those of you participating, I'm going to set up another challenge for you. And I'd like you to have a little think. And I wonder whether it might be the case that we can think about more than one way to explain the pattern this time. So there we go. We've got the 3 dominoes there. Let me just double check I've popped the right ones up. Yes, I have. So here we go. There are your 3 dominoes. What dominoes would come next? Perhaps you could post in the chat. I suggest you could do, perhaps I might refer to this domino as a 1-6 domino, just for ease of notation, maybe. What 2 dominoes are going to come next, and how do you know? Have a little think. Thank you very much. We've got some suggestions about what our next 2 dominoes might be. I don't know whether any of you had noticed that I haven't got 2 dominoes here turned upside down to reveal I wonder why that might be. Any suggestions, Charlie?
You've run out of dominoes.
Exactly that. I've run out of dominoes. We've got a 3-4 domino here, and as many of you have suggested, the next domino in our sequence would be 4-3. And of course, we've used that domino already here. Now, I think as long as we're aware of that as practitioners, we could make sure we've got a more than one set of dominoes. But thank you for your comments about how you thought about the patterns. It's really clear. Yes, and a couple of you have suggested that we don't need to why stop at 2 dominoes. Can we extend the pattern? And of course, it would depend. Let's have a think about that. If we extended, you've suggested rightly that it would be 4-3 next. I'm just going to imagine we'd have 5-2. Okay, and then what are we going to have? Some of you have suggested that actually it could be 6-1 next. What happens then? What might the next domino be then if we did continue? What could we do? Any suggestions? Okay, Jennifer's offered a possibility, 7-0. If there was such a domino. Is there such a domino? Well, it depends. Charlie, you look like you're about to say something. Oh, you're on mute, Charlie.
Let's assume there isn't such a domino.
Okay, that would be a more interesting problem, wouldn't it? If the
yeah, slightly trickier.
Slightly trickier. It is possible to get sets of dominoes which go higher than the 6-6 domino. That is possible, and so in some domino sets we might have a 7-0, 7 blank, I guess we would call it. But if there was no such domino, what might we do? We've had one suggestion of 1-6. I wonder why you're suggesting 1-6, Shapangi. Now, I'm not sure if I pronounced your name correctly. I'm terribly sorry if I haven't.
Liz?
Yeah.
Could you put your 1-6 turned upside down to the right of 5-2 so that we're all clear that what we're thinking about is the one that's going to come after 6-1?
Yes, thank you. Yeah. Repeat the cycle. Any other suggestions? Charlie, what would you do?
Well, I originally thought I would put blank blank, and
Can you
then
explain why?
And then I would put 1-6. But I'm no longer convinced, because what's special about the 3 that you had earlier and these 3 is that the sum was always 7, and the blank blank doesn't add up to 7. So I could see that 1-6, you've got to the end and you start counting again. But then you're not using the blanks. So yeah, and looks like somebody's supporting my idea of blank.
Yes. Yes.
So I might do blank, and then you sort of start the cycle again, and the numbers at the top are going down, and the numbers at the bottom, sorry, the numbers at the top are going up, and the numbers at the bottom are going down, and then you start with 1-6 and so on.
Yeah. Okay, really nice, really nice. Thank you for your suggestions. And I guess when we're reaching a point here that there isn't necessarily one answer, children's reasons become more important. Can you convince somebody else actually that your suggestion is a better suggestion than an alternative? Thank you, Charlie. Phil is suggesting that maybe we could count in base 6. Ooh, I'm quite intrigued about that, Phil. Depending on the age and experience of your learners, that could well be something you think about. So I'd like to just go back to the NRICH site at this point. So I'm going to stop sharing my dominoes and go back to the feature page. Bear with me. Here we go. So we're back on the feature page. So the task that we were just looking at is called domino sequences. And if I click on it, there are some images there, which you could use, of course, instead of dominoes yourself. I just thought maybe it's a bit more interactive somehow, having real dominoes, I thought. In case you're not aware, I just wanted to draw your attention to the fact that we do have teachers' resources with all our tasks, which you can find in this link to the left. And we always set out reasons for doing this task. What is the mathematics that is behind this task? How you could use it in the classroom under the possible approach, key questions, support ideas and extension ideas. And I wanted to draw your attention to this task, which we've linked for a possible extension this time. It's on the NRICH, it's on the feature page as well. Coincidentally, that's not necessarily always going to be the case, but just to share with you briefly, this is a similar idea. We're still talking about dominoes, we're talking about sequences. This time you're being invited to suggest what the middle domino is in this set of 3. And of course, you can adapt this idea. We're not going to spend very long actually looking at this task here, but you could adapt this idea and think about other ways to extend. What if you had more than one gap in the middle? Charlie and I had a conversation earlier in the week about, oh yeah, that could be quite nice if we had two unknown dominoes. And how would that make the challenge higher? How could we challenge children? Charlie, is there anything you'd like to say any more about those domino tasks? Or please, those of you working remotely, do post to the chat if you've got any particular questions about them.
Well, I'm tempted to draw something. Can I share my visualizer?
Yes, please do. Please do. That'd be lovely.
I'm in terms of what to do when, because it's a very dirty mug, I'll move it.
We'll pretend we haven't seen that.
In terms of thinking about what is happening as you go up the numbers and you get beyond 6 or you're going down, it just occurred to me that perhaps writing, wait a minute, this is, is it very bright? Okay.
Yeah, that's okay. We can see the 1 and the 2 you've written now.
Yes.
Perhaps, yeah, just focus in a little bit. That'd be great.
I'm going to have to move into the shade. The sun is shining through the window, and it's very bright.
Which is a lovely situation to be in.
Sorry about that. We should have. I'm sort of thinking of it a little bit like a clock.
Yes.
Can you see this now?
Yes, just about. So we've got 0, 1, 2, 3, 4, 5, 6 written in a circle.
Yes, and so it wouldn't be unreasonable to be thinking a bit like clock arithmetic.
Yes.
But when you go past 6, then you go back to 0. And then,
I think, yes, I presume that's Phil's point about basics, perhaps. Yeah.
And so then I think you could have sort of interesting questions with, I don't know, a 1 and a 5 on a domino, and then a gap or 2 gaps, and then I don't know, 2 and so no, you might not have 2, but you might have 3 and 1, and then so this is a bit like your middles.
Okay.
What would go next? And I'm wondering also whether you can work out sequences that use all the dominoes, or
that's a nice question.
I don't know, it's not something that we talked about the other day, but
no,
could you have a sequence? I'll stop sharing.
Okay.
Could you have a sequence that Because we ran out of dominoes a minute ago.
We ran out of dominoes for one of my sequences. Yeah.
But it'd be quite nice for students to make sequences themselves. I love the idea of having the dominoes and then students being able to guess and then
revealing. Yes.
And then revealing it.
Yes.
And I can imagine children making domino patterns and trying to maybe make quite a long domino pattern and maybe having one and another one which is sort of 4 away, and they've got to figure out.
Yes.
And I can imagine there may be some patterns where there's more than one possible solution. The further apart you go.
Further apart, depending on how many dominoes. Yeah, I think you're right, Charlie. Yeah, I think you're right. Yeah.
I think this is a great activity.
It has all sorts of possibilities, doesn't it? Yeah.
If people have got dominoes in their classroom.
Yeah. Let me go back to the NRICH site, because just before we leave dominoes, I'd just like to draw your attention to the fact that both those tasks we've had a look at, missing middles and domino sequences, are live tasks. And again, many of you may know what that means. Just in case you don't, it means that they're open for solution. They don't have published solutions at the moment, but if you click on this link on the left, submit a solution, your students could upload images, could type, you could send link to a video of them explaining. It doesn't have to be text, or you as a teacher could summarize what children in your class have done. And we look through all those solutions, and towards the end of this half term, so just before the summer holidays, we will publish a selection of solutions to these live tasks. We're particularly looking for those, as I say, that are well explained. So do encourage your children to send their thoughts to us. Okay, so let's go back to the feature page. And again, here we go. So I said that I wasn't going to say very much about what the feature was about. You've now had an experience of a couple of very similar, admittedly, but a couple of tasks, these domino sequences. And I hope that you get the idea of this element of the pattern in the sequence. So in some cases, it was Charlie explained it very clearly about that constant gap between each domino. We were counting in ones, I think, in one that we happened to look at. In some of the sequences that we didn't look at, there's an element of repetition as well, some repeating patterns. And although what we've done there in those two tasks are all in the context of number patterns, some of the tasks in our feature do offer opportunities for children to become more aware of patterns spatially as well. So do check out, for example, our repeating patterns task, our chain of changes task. These are all geometrical contexts. This article I want to draw your attention to very briefly is, although it's written for early years practitioners, I do urge you to read it, even if you're teaching older children. So the research shows that actually developing children's awareness of pattern gives children who are better able to describe patterns, identify patterns, actually go on to have a higher mathematical attainment, which is quite fascinating, isn't it? So Charlie and I are going to introduce you now to another task which offers a slightly different type of use of pattern. It's going to be developing, what we're going to be doing is we're going to be seeking patterns, identifying patterns, and then using what we know about mathematics, mathematical structure to explain why those patterns occur. So Charlie, we're going to play a game. I'm going to pop it up on the site. It's called Play to 37. I'm just going to make that a little bit bigger. Ooh, wrong way. A little bit bigger so you can see the image. I'd like you to imagine, Charlie, that you have 4 bags. We've got a bag full of ones, an unlimited number of ones, a bag full of 3s, a bag of 5s, and a bag of 7s. And we're going to take it in turns. It's a 2-player game. We're going to take it in turns to choose a number from one of the bags. And for example, if I chose a 5, and then you chose a 7, your 7 would get added on to my 5, which in that case would make 12, I think. And we'd go on making a cumulative total. And the winner is the player who reaches 37 exactly.
Can you just scroll down a touch so that everyone can see the rules there?
Yes.
Thank you.
There we go. I think you can just about see that then.
Oh, brilliant. So, okay, I understand this.
Okay.
So can I start, please?
Of course you can. Yes.
And do you want me to keep a running total?
Yeah, well, I'll do my best to keep it. Yeah, keep a running total. Perhaps just keep it on. You don't share it at the moment, but just keep a total so that we can just double check.
Okay.
So.
Okay.
Right,
I'll have 5, please.
Okay. I'm going to choose. I'll choose a 5 as well.
Okay, so that's a total of 10.
10. Yep.
I'll choose 7, which makes a total of 17.
Okay. Yeah. I'm going to choose 3, so that takes us up to 20.
Okay. I'll choose 3 as well.
Okay.
So that's a total of 23.
23. Oh, we're getting closer, but I'm not quite within reach yet. Okay. I'm going to choose a 1. 24.
That's a total of 24.
Yeah.
I'll choose a 5.
Okay.
Which is
So
a
that's
total of 29.
29, and we're aiming for 37. Oh, I'm still not within reach. Okay. I'll choose a 1 again. 30.
Okay, so I think I can win now. I'll go for 7, makes a total of 37. Was that beginner's luck?
Do you know, I think I know why you wanted to go first, Charlie. What about those of you watching? Do you think that was beginner's luck, as Charlie postulated or teased me, should I say? Or do you think Charlie wanted to go first for a particular reason? Just have a little think. Post any thoughts that you think are relevant. Remember what I said at the beginning, doesn't matter if your reasoning is not fully formed. If you think that something's important, pop it in the chat. And then perhaps we'll have another game in a second, Charlie. Let's wait to see what everybody thinks. Really nice. Thank you to those of you who have contributed. We've got a nice mixture here of some of you who are putting forward a conjecture without necessarily at the moment giving any reasons, or and some of you, Annie's point, I think, is a really important one. She's looked at the numbers that are available and has noticed that we only have odd numbers. This could be very useful observation. Some of you seem to be suggesting that, yes, you can only win if you go first. So is it a question of you can only win if you go first, or is it a question of you're more likely to win if you go first? I wonder. Charlie, shall we have another go? But perhaps we should.
Yes, and also, is it inevitable that you're going to win if you go first?
Right. I mean, good question. Could I go first and actually lose if I wasn't paying attention, I wonder? Should we have another go? And this time, perhaps we should record as we're going under the visualizer. Should we try?
Okay.
Yeah. Do you want me to record, or are you happy to? Or
well, yeah, I think, let's see. It's gone slightly cloudy here.
Okay, go on then.
So it might be possible.
Yeah.
Let's see what happens.
Thank you. So far, you have been very good at identifying some patterns that you've noticed. So okay, Charlie, this is really helpful because you've got the recording of the previous game. Let's have another go. And if you wouldn't mind recording next to it so we can see both, I think that would be really helpful. Can I go first?
No.
All right, go on.
Okay, you can go first. You can go first.
Thank you. Okay, I'm going to start this time with 7.
And I'll choose 5, which makes a total of 12.
12, okay. I'm going to choose 5 as well, please. So I think
Makes a
that
total of 17.
Mm-hmm.
I'll choose 5 again. Makes a sum really easy. 22.
22. Okay. I'm going to go up. I'm going to add on 7, please. So 29.
And I'm in trouble now, because if I choose 1, you're going to choose 7. If I choose 3, you're going to choose 5. If I choose 5, you're going to use. We're 8 away, so whatever I choose. So I'll choose 3, and yes. I'm trying to cheat and hope you don't pay attention and do the wrong sum, but I think I've given away too much. Okay, 32.
So you added on 3, okay. Well, 32, I'm going to add on 5, I think. So I win.
You do win. Okay.
So those of you watching, now you can see that the recordings we've made there. The first time round, interestingly, we had more goes. We had more turns, didn't we, Charlie? How many turns did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so first time round we had 9 turns. Second time we've only got 7. Okay, but in both cases the first person won. Any other thoughts, those of you participating? Do you see anything, any patterns that you notice, or anything about those number of turns that we took? Some really helpful comments coming up. The second person will always get to even numbers. I wonder why that is. Stacey's reminding us that an odd number and an odd number is always an even number. And how does that help in this case, Stacey, I wonder? Right, Margany, I'm not sure, apologies again, I might not have pronounced your name properly. You're looking down, I think, the list, and you're right. We seem to alternate between the first number has got to be odd, hasn't it? Because we've only got odd numbers to choose from. But then, thank you, Charlie. But then we've made an even total. Now, why have we made an even total? Well, I guess Stacey's comment is key there, because Stacey's reminding us that an odd plus an odd number is always going to be an even number. Thank you, Charlie. Yeah, so Stacey said, so your target is an odd number. 37 is an odd number. So you need to be person 1, because as is pointed out, person 2 is always making the total even. So at this point, I mean, we have raced through this. In the classroom, what you might do is, once you've had a go at playing the game, perhaps, you know, if you've got an adult in your classroom, you could play against, like Charlie and I have done, you could do that. You could play you against the class, and you could record. You could encourage the class to play in pairs. And then what you might do is you could encourage everybody to share how many turns it took. You might encourage them, you know, to let you know if anybody found that the second person did win. And you'd want to make sure that children were recording all the time, so that, you know, you could check their arithmetic, of course. And then it's a question about, you know, what do you notice? You might at first suggest, well, can we, you know, what is the largest number of turns we could take for this game? What's the smallest number? Just going to restart again for some reason. So there are lots of questions that you can be asking along the way to scaffold what we're doing. We have jumped here quite quickly. But you've offered some really lovely explanations. What you could do then, and Charlie, you may want to chip in, you could invite your class to tweak the game to satisfy different conditions. So you could say something like, well, could you give me an example of a game that we could play where the second person would win? Or what could we do that it would make it possible for the second person to win? Is there a way we can play so that the second person always wins? What would have to change? And that can really encourage children to unpick their understanding. Charlie, have you got anything that you'd like to add?
Well, I suppose I'm curious about how people would explain that two odds make an even.
Nice. Yeah.
And let me get a clean sheet of paper. Unfortunately, the sun seems to be coming out again.
Well, I could put my visualizer on if you like. See what happens when you will scribble and.
I'm going to. There we are. I'm going to create some shade. And one of the way, there's a pictorial way of describing numbers. So if I have a rectangle split up into, imagine they're all the same size square. I don't have to count the number of squares there to know that there's an even number, because I can tell that I could share that between two people, and one person would get the top half and another person would get the bottom half, and that would be evenly distributed. So if I add one more square, that must now be an odd number of squares. Now let's imagine I'm going to add that to another odd number.
Yeah.
And these rectangles that I'm drawing could be any length. They could be, but if I imagine the original one was even, and if I add one square, then I would have an odd number. And now I can imagine putting the two together. And if I put the two together, then I'm going to end up with something like this being connected with something like that. And so the odd one out from the left number and the odd one out from the right number will combine to make a pair. And then I will be able to know for sure that the sum is an even number. And so this would convince me that two odd numbers make an even. And I can also, it can also help me see, well, if I have three odd numbers, well, I'm sort of adding something else here, which is odd. And then if I add a fourth one, I'm then going to get an even, and a fifth one's going to be odd. And so I love this diagrammatic representation that allows me to see why the sequence is going to go odd, even, odd, even, odd, even.
Absolutely, yeah. Thanks, Charlie. That's really useful, really useful. So in that task then, we were collecting results almost. We were looking at the patterns from results from the games that we had played, and then we were explaining those patterns using the mathematical structures, using mathematical concepts that we know. So that feels a little bit different. That's a slightly different angle on pattern. I'd like to share now one other task. By the way, please do, if you have a question or a comment, please could you pop it in the chat, and we'll do our best to answer that way rather than turn on microphones. Thank you. Okay, I'm going to go back to the website. Incidentally, this let me make this a bit smaller again. This game, Play to 37, is also a live task, so you've got to submit a solution there. So do again send your children's thoughts and ideas to us. So let's go back. Charlie, I've got one last task I think we've got time to have a go at, and it's called digit addition. I don't want to at the moment click on the task because I don't want people to read ahead. So what I'd like everybody to do, please, is choose a number from 1 to 9 inclusive. So you could have 1, you could have 9. Just hold it in your head, a whole number. Add 9 to it. So add 9 to your number. And now, could you add the digits of your answer together? What do you notice? Perhaps you could post in the chat. Or Charlie, I'll hold off asking you. What do you notice? So let me just remind you what I think you've done. You've chosen a number from 1 to 9. You've added 9, and then you've added the digits of your answer. What happens? Okay, Charlie, what happened in your case?
I started with 7 and I ended up with 16, and the digits of 16 added up to 7.
Okay, so you got back to your original answer.
I did.
Your original number, I should say, sorry. And that seems to be, thank you those of you who have posted, that seems to be what happened to other people as well. So in the classroom, you could encourage children, you know, every child could have a go at this. What happens? So I think you probably know what my question is going to be. Why don't we check one more time? Choose a different number this time from 1 to 9. Add 9 to it. Add the digits of your answer. What happens? Charlie, what happened?
The same.
The same. Good. So in the classroom, we at NRICH, we like to talk about children being young mathematicians. And as a mathematician, noticing patterns, noticing something such as the answer always seems to be the same as the number I started with is fantastic. It's the first step. And as I say, that raising awareness of pattern has been shown to correlate with mathematical attainment. However, mathematicians aren't satisfied with just noticing that they think something might always happen. We want to be sure. We want to try and explain. So our conjecture is, well, this always gets back to our starting number. How do we know? How do we know that we just haven't tried that one number where it doesn't happen? So I'd like you to have a little think. How might you begin to explain this? Again, don't worry if you've not got a fully formed argument. What do you think might be important here? Charlie, I'll come to you in a second. So why is this the case? Why is this the case? Have a little think. Post in the chat, please. What I'll do now is I'll actually show you the problem on the site so that you've got in front of you what we're doing, just as a reminder. Thank you, Phil. Phil's offered some thoughts, thinking very much about place value. Any other offerings from anybody? From Charlie, I might come to you.
Are you coming to me now, or are you waiting?
I was pausing, but now I am coming to you, Charlie.
Right. What is your question for me?
So my question is, Charlie, why does this happen? Why, when we start with a number from 1 to 9, we start with a number below 10, we add 9, and then we add the digits. Why do we always get back to our starting number, Charlie?
Okay, so my explanation would be that if instead of adding 9, like you asked me to, I added 10.
Yes. Well,
adding 9 is the same as adding 10 and taking away 1.
I agree.
So I'm going to change what I do, and I'm going to think of it as adding 10. Well, if I add 10 to a single digit number,
yeah,
I will have 1 in the tens column,
yeah,
and the same number that I had before in the units column.
yes.
So now the sum of the digits will be 1 more than what I had before. But because you wanted me to add 9 and not 10, I then have to take 1 away from the units column. And so the number in the units column is going to be 1 less than what I had before.
Mm-hmm.
So I add 1 to the tens column, but I take 1 away from the units column. And so the total is going to be the same. So
Right. Yeah, thank you, Charlie. That's it. Shall we have a look? I've got some, let me show you under my visualizer. I've popped up I've got here a Blue Peter style readily, which isn't showing. Okay, there we go. Here we go. Here's my place value chart. So Charlie, give me an example of a starting number.
7.
7, right. 1, 2, 3, 4, 5, 6, 7. Okay. So talk me through your reasoning. So we've got 7 ones.
And no tens.
And no tens.
So instead of adding, I find it difficult to add 9. I find it much easier to add 10.
Yes.
And then take away 1. So I'd like 1 in the tens column.
Yeah.
So that now stands for 17.
Yes.
But you asked me to add 9 and not 10. So I'm going to have to take 1 away from the units column or the ones column. And so the number of counters is the same as I had before.
Right. And why is that always going to be the case?
Because adding 9 is always the equivalent of adding 10 and taking away 1.
Right.
And you asked us to have the number in the to start with a number between 1 and 9. So I was always going to be taking 1 away from the ones. So I was going to end up with anything between 0 and 8.
Exactly.
But what I think this shows me, Liz,
yeah,
is that I could change your game.
Oh yes, go on.
Well, if you'd said to me, add 99,
Ooh. Mm.
the result would be the same. Because adding 99 is the same as adding 100.
Yeah.
So if you want to add a column to the left of your tens and call it hundreds, and let's imagine I start with those 6 blue counters that you've got there on the right,
yeah,
and nothing in the tens.
Yes.
So if I start with 6 and you say add 99, oh, this is too difficult for me. So what I'm going to do is I'm going to add 100, and then I'm going to take away 1. And
nice.
so
the digit sum
would be the same.
Yeah.
And I think if you said to me, add 999 or 9,999 or 9,999,999, I'm still going to end up.
Isn't that lovely?
Because what I'll do is I'll add 1 more than that and then take away.
Absolutely. How nice. So not only can we generalize from our starting task using numbers 1 to 9, why is this always happening? But now, Charlie, you're suggesting actually this is going to happen if I add, like you say, 99, 999, 9,999. How wonderful. Okay, well, what would happen, Charlie, if we stick with our same starting point? Let's say, for example, we've got 5 here. What would happen if we added 19, I wonder? So this time we're going to add 19. Then we're going to add the 2 digits of our answer again. So just have a go at this. So let's starting number between 1 and 9, add 19, add the digits of our answer. What's going to happen this time? Would you post in the chat what's happened? We'll just re-echo. We've got a starting number 1 to 9. We're adding 19. And then we're adding the 2 digits of our answer. Charlie, what happened to your number?
Well, I'm thinking of that's the same as adding 20.
Okay.
So I'm adding 2 new counters,
Mm-hmm.
and then I'm going to take 1 away.
Mm-hmm.
So the total is going to be 1 more counter than I had before.
Nice.
So my prediction is that if instead of adding 19, you ask me to add 29,
Yeah. So let's go back to our original number.
that's going to be the same as adding 30 and take away 1.
Yeah.
Adding the 30 adds 3, but taking away 1 takes 1 away. So I'm going to end up with 2 more. And so I can start to generalizing in that direction.
Exactly.
My suspicion is if you ask me to add something like 79.
Yes.
That's the same as adding 80 and take away 1.
Mm-hmm.
So I'm going to end up adding 7.
Yeah.
My total will be 7 more. So,
Isn't that nice?
children can generate. What's nice is this. And then we could also start thinking about what happens if we add 119 and 120. And we can make predictions about all sorts of.
Absolutely. Yeah. So here we've got, thanks, Charlie. Yes. So here we've got a task where we're noticing the patterns. We're drawing on our knowledge, this time of place value, to explain those patterns. And actually, we're then asking, it could be you as the teacher asking the follow-up questions, but the more that you as the teacher ask follow-up questions like these that Charlie and I are posing, you will find that the children ask their own follow-up questions. And I think that's one thing that possibly we don't offer children enough experience of, asking their own questions, posing their own questions and following up themselves, rather than always working on mathematics that somebody else has put in front of them.
I mean, the other thing that I think is also really interesting, which possibly doesn't happen very often, is for the teachers to ask questions in a way that suggests that they don't know the answer.
Yes.
Like, oh, yes. I wonder, is there anything else, so we did it with adding 9. Is there any other number that we could have added and it wouldn't have made a difference? So the 99, for example.
99 might come up, yes.
And that I know some teachers who ask questions, they know the answer, but they ask them in such a way that suggests that they're not quite sure.
Yeah.
And then I think there's a different dynamic in the classroom when that happens.
Absolutely. It's not so much teacher as expert then, is it? It's the community of mathematicians working together. Yeah, absolutely. Thank you, Charlie. That's really helpful. So I think I'm going to stop sharing my beautifully constructed place value grid and go back to the website quickly. And we're rapidly approaching the end of our afternoon together. But just to let you know, this digit addition task, it's not live. So there are some student solutions on this occasion. I will leave you to have a look at those. If you are interested in sending solutions to us, what I failed to mention so far is that the deadline this time is Monday, the 11th of July. So you've still got a good few weeks to share these tasks with your learners and encourage them to create their own solutions. Charlie, is there anything more you'd like to say about that particular task?
No, except that somebody in the chat has suggested what would happen if we added negative numbers. We don't have time to think about that, but that seems, again, an interesting extension here.
Absolutely. Yeah, really nice, really nice. So we are almost at the end of our afternoon together. I'm going to pop back a PowerPoint slide. Some of the links that are on the PowerPoint slide, we've already explored on the site, so I'll just remind you quickly of those. And the PowerPoint, a PDF of the PowerPoint slides will be available. I'll explain where shortly, so that if you don't get a chance to scribble down, then you can find it on the NRICH site. Let me just get the PowerPoint back up. Here we go, and like that. And then I'm going to share it. Notice I feel the need to talk about what I'm doing. There we go. Okay. So I'm hoping you can see that PowerPoint slide now. So do keep in touch with us via Twitter if you're on Twitter, and that's our Twitter handle. Alternatively, you could sign up for our email newsletter, or as well, of course. Those are the best ways to find out what we're up to and to be notified of upcoming events. There's the link to the primary mapping document, which I mentioned at the start of the webinar, which takes you to the Google Sheet, which links NRICH tasks to maths curriculum objectives. There's the link to the past features. We've focused today on our pattern and structure feature, but that link will take you to all the previous ones. And again, that link is also in that top right-hand blue box on our primary teacher homepage. This is the link for the page on which we will post a recording of today's webinar. The webinar we did yesterday for secondary practitioners, the recording is up there already, so you may be interested to see that. So do encourage your colleagues to watch, should you wish, and do share that with whoever would be interested. On that page as well is where you'll find the PDF of these slides. Finally, and Ems has already posted this in the chat, thank you, Ems, please do give us your feedback about this afternoon session. We're always trying to make them better received, to include things that are useful for you in the classroom. I think that brings us to the end of the session. Charlie, you've got your finger up. You'd like to say something?
Can I just say one more thing? It just occurred to me that sometimes mathematicians enjoy showing tricks to children, mathematical tricks. And I'm always slightly concerned because the danger is that children who already find maths mysterious then find it even more mysterious. It's like, how on earth am I supposed to understand all this?
Yeah.
And then there are these look like magic tricks. Yeah. What I really like about the problems you've shown us, or you've shown me today, Liz, and that you're offering, is that both with the Play 37 and just now with this trick, there was an accessible explanation, and that, you know, whether it's Play 37 and we've got the odds, evens, odd evens idea, or here where we can think about adding 9 as adding 10 and subtracting 1, or adding 99 as adding 100. There is a trick, but there is also an explanation. And so children don't leave the classroom feeling that this is something that is only accessible to a small minority of sort of very sort of geeky kids. So I'm not usually very fond of tricks because there's always that danger. But
yes,
I really liked these tricks because they can be explained, and then you can build on them, and you can get to, you know, oh, can anyone predict what's going to happen if I add 5,260?
Yes.
Well, I think I can predict that, you know, and that feels quite empowering. And okay, go home and try it with your parents, and you know. So okay, so sorry,
no, it's really useful to say, because actually I had meant to, because that last one we tried, it is cool. It is referred to as a trick, and I had meant to mention that. So thank you for doing so, because I forgot. Good. Okay, well, thank you all for participating. We hope you've enjoyed this afternoon session, and that you will take these tasks, use them with your learners, and also don't forget the others in the feature that we just haven't had time to explore this afternoon. Thank you very much, and we hope to see you at a future event. Bye for now.
Bye-bye.